Hi, my name's Dan, and I study game theory, and economics, and how it applies to video games. So today we're going to talk to something that I'm calling the Ganker's Dilemma. For those of you that don't know, game theory is a mathematical tool used in a lot of things: economics, political science, even like biogenetics. It's crazy. However, we use it as game designers to incite players into certain behavior. For example, ever wonder how many monsters a certain spawner should have? Well, the answer varies based on a lot of things, but let's go ahead and focus on using the number of monsters available to make our players want to fight. What the heck is this? Well, it's called a strategic form game, and we'll use it to demonstrate the soft friction that we want to create between our players. So, each player is going to have two options, whether to farm or to gank, and inside each of these boxes are payoffs, and the left number being for player A and the right number being for player B. If players decide to farm, they'll get 2 mobs each if both players decide to farm. However, if either of them chooses to farm while the other ganks, they'll get 0 mobs while the other gets 3, because the person who's choosing to farm will be dead, while the other person gets the whole spot to themselves. Lastly, if each decide to fight, they'll only have time in order to kill a single mob, as they'll be busy, going back at each other the whole time. So what happens? Well, in this scenario, given this criteria, each player actually has a dominant strategy to gank the other, regardless of what the other player is doing. So let's say the player A wants to farm. Well, player B's best response is to gank them and get the whole spot to themselves. If player A is farming and player B is farming, then player A is actually incentivized to switch strategies and gank player B. So, likewise, if player A knows that player B will gank them, then their best response is to gank them back, as it's better to get 1 mob than none. So here we've modeled our farming spot. We have 1 player killing the monsters. They're able to kill 3, and we're making sure that there's 4 that respawn on a timer. You see our player getting XP, and we're going to go ahead and take a look at what's going to happen when we add in that second player and give them the options that we saw in our chart. We're going to give them the Ganker's Dilemma. Okay, here we are at our collaborative solution, where both of our players choose to farm, and they'll split up evenly, and they're playing nice. So each player is only getting 2 mobs at a time, and the entire spawn is exhausted. However, we know that this isn't a thing that this isn't a stable equilibrium. Somebody's going to budge, likely to budge, and want to gank the other person. So let's say that player B on the top is going to gank player A, and we'll go ahead and switch over to this solution. Now player B is getting all of the XP, while player A gets nothing. That's because player A is dead. They've been ganked, because they've just been trying to farm. Meanwhile, this person is killing them and then taking all of the farm. So we know that the response to being ganked is to gank back, which gets us to this, which is our competitive equilibrium, where both players are the worst off. They're getting the least amount of XP for their time because they're spending most of their time fighting. And so one of the things that this program is able to do is you can go ahead and actually chart these. So you can see here that we have a stacked chart of each of the players' outcomes and their payoffs cumulative over time, continuing to be in this state. So what ends up happening here is you see that the worst off players are the ones who are fighting. The best off player is the one who's fighting somebody who's not fighting back. And the competitive or the collaborative equilibrium or collaborative solution is actually where our players would be if they didn't have the incentive to try and get this higher amount. So why might you create a solution, a system like this in your game? Well, sometimes you want to maybe take the players, you want to slow down the economy a little bit in order to avoid inflation in your game, so you end up putting in things like this to slow down that resource acquisition, or you're saying, okay, I want to create a place that has really really high rewards, and I want people to be able to fight over it because that's some of the content, and specifically engaging in that would be how players find enjoyment in the game. Games like Eve do this. They create soft friction in order to make it so that the players will want to fight each other, given that there's just a limited amount of space and that there's just not room in the galaxy for everybody. So this kind of system would be implemented for that. Now, I'm sure that you're thinking, okay, well, that's weird because I have played games before and I've been in the solution where we're both farming. I'm next to an alliance member and they're killing stuff and I'm horde, and we could fight each other, but we're just choosing not to. So that can happen for a lot of reasons, and I hope to get into those reasons in the next video where I talk about the repeated Ganker's dilemma. And in that video we're going to go ahead and say, okay, well, what's going to happen when these players are going to learn from each fight or each interaction with each other? How can players get to this collaborative equilibrium and have the best overall total surplus, or total surplus being total amount of XP for everybody. So I hope that you join that. Thanks for watching this, and like, comment, subscribe, and I hope to see you next time. Bye, y'all.